Hello, everyone. I was told there will be only 20 people in this room. Thank you for showing up. My name is Aysegul, and I'm here to talk to you about creating 3D components using Angular and Three.js. A little bit about me. I worked as a software engineer at Autodesk, specifically on their A360 cloud team. So what we do is create a platform for people to share their 3D files in any format and collaborate. I will show you a little bit what we do. I also work for this great organization called Anycannons. Our mission is to teach human trafficking survivors how to code. And check out what we do on anycannons.com. So today we will go over what a 3D component is, what WebGL is, and why it's important that we create separate components with Angular, and why I'm so excited about it. And lastly, we will go over some code and see how it's done. How many people are familiar with WebGL? That's a good crowd. So WebGL is a 3D API that allows us the full capabilities of the GPU to create very smooth animations. Like the 2D Canvas API, it's all done through JavaScript. Now, when I say 3D graphics, most people think of games, and that's the big chunk of it. But 3D is all around us. There are so many things that are being created with 3D programs, like this building and the cup that you're drinking your tea, to things like we have 3D scans of our brains, and then we can run simulations to test physics. And these are all stuck in some desktop program. So what WebGL allows us to do is bring that all to the open web. So we can share, we can collaborate, and we can do much more with it. So I will try to show you what we do at Autodesk with that, because we do use these technologies, WebGL and Angular, to create this platform that you can share. It's so hard to see. So you can upload your files and look through them in 3D space and share them with other people and take it apart and bring it back. And if it's a building that you are looking through, you can just walk through it, and it's a really cool thing. And we used around 150 Angular directives to create it, and our WebGL API. So going back to our slides, WebGL is available on all modern browsers and also on mobile browsers as well. WebGL also allows us to create virtual realities, and that is also available on the web. Before, if you create a virtual reality app, you would have a huge download. Now you can just create it on a browser. Today I will not write any WebGL code because it just takes a long time. Instead, I will use Three.js, which is a library that has pre-built WebGL objects and some methods. And it's really fast and intuitive to learn, and also it's optimized. And I promise you a brand new world at the end. So this is what we will build. And the code will be available on GitHub. So why are we putting this inside a component? Because we can have the nutritious WebGL and then the delicious Angular directives, and wrap it together so we can use it in different parts of our applications, and we can create some customizations and make it available for our designers, for example. Let's go through some Three.js code. First thing is that we need 3 things to create a scene. Scene is a root object, just a JavaScript object that holds together everything that we have, that we want to render. And we need a camera to look through to our scene. lastly, we have to render everything through a renderer, through our camera. To create a scene, we instantiate a new 3 scene. And then we can use the camera to look through to our scene. We have a couple of options for camera. Perspective camera is what we will stick with today. And if we look at the arguments that the perspective camera takes, it's field of view, which I can't explain, and the aspect ratio. Aspect ratio is important because if you don't put the aspect ratio to the width and the height of what you want to render, then you will have a distorted image. And the third and the fourth thing is the near clipping and the far clipping, which is what we will see through our camera. So anything before the near clipping won't be seen. Anything further far away from the far clipping won't be seen as well through our camera. Then we instantiate a renderer. So we have few other rendering options. If WebGL is not available for some reason, there are fallbacks like the canvas renderer, but WebGL is the fastest one. You can set the size of your renderer and then just append it to your document. So far, we have a scene, we have a camera to look through, and then we have a renderer, and with append it to our DOM. And what we see is just darkness. Because we are looking at a room that has no light, no object. We are just filming an empty room. So for that, we need to create some objects, 3D objects. 3D objects requires 3 things as well. First thing is the geometry, which defines the shape that you want to render. And the second thing is the material, which defines how the light will reflect through, over your material, and the bumpiness and the smoothness, so on and so forth. And also, at the very end, we have to create a mesh that will use this geometry definition and the material definition to create the actual vertices and the triangles. So here we have a very simple cube geometry, which takes 3 arguments with height and depth. Like so many other open source projects, the documentation might not be super good, but the good news is that the source code is very readable. If you go to the source code, you will know what kind of arguments the methods are taking and then what they're doing. Also, Three.js has a great examples page that you can look through the examples and then see the code and try to figure out what you can do with it. There are a bunch of examples of materials as well. So we are going to use a basic mesh material. And then we can give it an option for the colors, for the bumpiness, and other for texture mapping, so on and so forth. Another very cool material is the depth material, which renders anything that is close to your camera white and anything further from your camera close to black. Finally, we create a mesh and from the definition of our geometry and material and add it to our scene. One last thing to be aware of is that everything you create with Three.js will be created on the exact center of your scene. For that, things might be overlapping each other, like your camera and the cube. And you have to move your camera to be able to see what else is there. So we have everything, but we are not rendering yet. We have to also create a rendering loop. So if you're not familiar with animation, you might say, to create a loop, we can just use a set interval. But instead, there is this request animation frame method that we can call our render function with. What request animation frame does is that calls the render function before the actual rendering happens 60 times per frame. Nothing, I mean, 3D is worthwhile if you're not animating. And animation is pretty straightforward. You just change the rotation or transformation of your objects. We can also group things to transform all together. So I'll show you what we have so far. Is this cube, which I use the depth material instead. So I don't know if it's easy for you to see, but the corners that are further away are darker than the closer ones. All right. So let's wrap things with Angular directives. How many people build their own custom directives? Well, pretty much everyone. That's great. But I will talk to you about very simple concepts on building your own custom directives, because I also want to point out how similar it is with Angular 2. So when we build our custom directive, we call the directive method with 2 arguments. One of them is the name of our directive, which we will match our directive function with when Angular goes through the compile and goes through the DOM for the first time. So we have the name, and then we have the factory function. And it is exactly the same with a little bit cleaner syntax, in my opinion, with Angular 2. What you have is a annotation for directive, and then the selector. So you give the name of your directive to that selector, and then you have a constructor function. One thing I take advantage of pretty often is the Aysegul scope. So it might be confusing at some times why we want to use an Aysegul scope, since we have access to the parent scope anyways. The reason is that you don't have to inherit everything from your parent scope, and you can just define only few of the things that you want to have access to. That way you are limiting your access to your parent scope so that you won't change things by mistake, and you know what you have access to on your directive. This is especially very good if you're going to use your directive in more than one places with different controllers. And as you might know, we have a few options. We have the two-way data binding with the equal sign, and then we have the add attributes for static value and expressions. If you're going to use your directives components in different places, you might not always know what kind of attributes you have access to, and people will use it in the way that you intended to. So it's a good idea to make these attributes to be optional so that you don't get errors. So the question marks does that. And the star allows you to shallow watch the binding. And if you look at it in the Angular 2, instead of the scope, we have the inputs, which is an array that takes string values. Like we have the radius and height in this case. So our linking function does everything that we did before. So it creates a scene, it creates a camera and a renderer. Instead of appending it to the DOM directly, we are appending it to the element of our directive. And here, additionally, I added some lighting, which is the directional lighting. Since I have the scene, there are two things that I had to create my globe. One thing is the globe with the earth texture, and the other thing is the clouds with a transparent texture. So they're basically the same thing. They're just spheres with different size and different textures. So why keep writing the same code over and over in our directive? And we're not doing any DOM manipulations in these functions. So it's a good thing to do, just move your code into a factory or a service so you can reuse it. Here on my globe factory, I'm defining the bump maps and the image URLs. And then I can return the create sphere and create cloud functions to be used in my directive. So the create sphere function just creates the globe geometry and then the texture maps. And also, I have some material options added here and then created the foam material. And lastly, I create my mesh and then return that mesh. Once I have that, I can inject my globe factory into my directive definition. And then I can just use those methods to create the spheres added to my scene. In Angular 2, the injection works in very similar ways. If you are injecting from a parent component, you can just include it inside your constructor function, or you can use the injectable decorator. Let's see what we have built so far. I added some animations, and there are a few more lightings, but the rest of the code is on GitHub, and you can find it at the end of my slides, the link for it. And that's it for my talk. Thank you very much for listening. And Autodesk is hiring, and I have some T-shirts for you. And see you at the AMA at the very end. Thank you.